All right, these problems are some application problems or word problems dealing with quadratic functions. First thing you need to know is all of these problems will be on the calculator portion of the exam, so I don't expect you to do any of these without your calculator. I'm going to work all of these out algebraically, and then I'm going to rework all of these same problems out, but using the calculator, so you actually see this video twice, but worked out two different ways. When it comes to the test, you will select which method you prefer. So maybe you want to do the algebra, maybe you want to just use your calculator. All right, so the first problem says the price of gas through the month of March is modeled by y equals negative 0.014, etc., etc., where x equals 1 corresponds to March 1st. Okay, so that's important. So we know our x-coordinates are days in March. On what day in March did the gas price reach its maximum, and what was the highest price in March? So without graphing anything, I do know that this quadratic, because a is negative, is going to open down. And I want to know on what day was the gas price at its maximum. Well, maximum aka vertex, right? So I need to find that vertex. Now if you think about, if I know the vertex, the x-coordinate, so we want to find the vertex, and we know that this equation is in standard form. So I know that the vertex for an equation in standard form is the opposite of b divided by 2a. So if I take my b value, 0.448, but make it negative because it's the opposite, divided by 2 times a, and do the math, that equals 16. And then I can find the y-coordinate, just in case I need that, by plugging 16 in for x. And again, doing that crunching. And that equals 1.26. So my vertex is 16 and 1.26. Now let's make sense of this in context to the problem. On what day in March did the gas reach its maximum? Well, x is the days of March, so on the 16th of March, gas was, and the y-coordinate, of course, is the price of gas, so $1.26. I certainly wish it was still $1.26. All right, next one says from 1990 through 1996, the consumption of poultry per capita is modeled by the following quadratic, where x equals 0 is the year 1990. During what year was the consumption at its maximum? And again, anytime you see maximum or minimum, that should trigger in your mind vertex. So my quadratic, because a is negative, is opening down. So I want to find the maximum. And again, that's vertex. So because it's in standard form, the vertex is the opposite of b divided by 2a. So pause the video and try this one on your own and make sure that you can, get this math and make sense of it. But I will obviously work it out also. So x equals 6.15 approximately, and then plugging that in for all of the x's to get y. And that is 64.37, etc., etc. So my vertex is 6.15. Let's try that again, 6.15 and 64.37. Now to answer the question, during what year was the consumption at its maximum? Well, if x equals 0 is the year 1990, then x equals 6.15 would be 6 years later. So 1996 was the year where the poultry consumption was at its max. All right, this one says the path of a football can be modeled by the following quadratic, where x is the distance in yards the football is kicked, and y is the height in yards the football is kicked. Part A says find the maximum height of the football, and Part B says how far did the punter kick the ball. All right, so a couple things we know. We have a negative parabola again, which makes sense because if you visualize the path of a football, you're going to kick it and you're going to come back down. So that is logical. Finding the maximum height of the football, again, would be the vertex. So I need to find the vertex, that's for sure. Now the x-coordinate of that vertex is not the maximum height, but the y-coordinate is. So I need to find the y-coordinate of the vertex to answer part A. How far did they kick the ball? Well, if the punter starts at the origin, which we assume because you don't start at a negative distance, then wherever it ends would be how far. Well, if I know this is the x-coordinate, knowing also that parabolas are symmetric, if I double that x-coordinate of the vertex, I should have that distance. So, again, I have a standard form equation, so I can use the opposite of b divided by 2a to figure out what that x-coordinate is. And x equals 20, and then y is going to be replacing all of the x's with 20, and y is 15. So my vertex is 20, 15. So that means I have a maximum height of 15 yards. And it went over 20 and 20 again, right? So my punter kicked the ball for 40 yards. So pretty slick, all the things that nice vertex will tell you. All right, last video. You are making a coffee table with a glass top surrounded by a cherry border. The glass is 3 feet by 3 feet. You want the cherry border to be a uniform width. You have 7 square feet of cherry to make the border. What should the width of the border be? All right, I definitely need a picture. So I have a piece of glass that is 3 by 3. This is my glass, and I'm going to put some cherry border around it. That's uniform width. All right, let's see how uniform I can make this look. Oh, not very uniform. Anyway, this is of uniform width. So like if this is 2 feet, this is 2 feet, this is 2 feet. But I don't know what that is, so I'm going to call it X, of course, because anything we don't know in math, we call X. All right. So, and I know that this cherry border going all the way around, in fact, I'm going to kind of just draw an X through my glass because I really don't care about that. So my cherry border going all the way around is 7 square feet. So if I could come up with an equation for just my cherry border and set that equal to 7. Well, what if I took my whole table, subtract out the glass, and then I'd have that cherry border, right? So I'm going to need the entire length, okay, so that's x plus 3 plus x, right? Which obviously is 2x plus 3. And then I know that this is a square, so I know that the width is also going to be 2x plus 3, but certainly check that if it doesn't make sense. So I know that 2x plus 3 times 2x plus 3, so squared, minus the glass, which is 3 by 3, so 3 times 3 is 9, should equal that 7 square feet of cherry border. Okay, now this, if I FOIL this out, means 2x, in fact I'm going to write this out, 2x plus 3 times itself. Okay, so FOIL that out, so 2x times 2x is 4x squared. My outer term is going to be 6x, and my inner term is another 6x, so if it's okay, I'll do that combination all together. 3 times 3 is 9. Those cancel out. I'm going to subtract the 7 over so that I can set it equal to 0. Now, before I go on, I want to show you another way that I actually think is easier. I'm going to redraw this picture, okay, with this uniform border here. If I take my cherry border pieces and draw in the squares and rectangle, I know that this x times x, this corner piece, has an area of x squared. All the corner pieces have an area of x squared because the table is square, right? I know that this rectangle piece, this is a 3 because that's the glass, and this is an x, so length times width, 3 times x is 3x. So I know all these rectangular pieces are 3x's. If I add up all those cherry border pieces, 1, 2, 3, 4, x squared, 3, 3, 3, 3x, so 4 of those 3x pieces, 4 times 3x is 12x, would equal 7, I'd have the same equation. Now to me that's easier because I bypass these steps right here. Just a little bit of extra work if I go route 1, but whatever makes more sense to you. Clearly, you're going to get to here no matter which route you take. Okay, so back to the problem. I need to solve this. So how do you solve it? Well, I don't know. Is it factorable? Let's try. Hopefully it is. So let's see. Well, I know that factors of 7 have to be 1 and 7. Factors of 4x squared are either 2x and 2x or 1x and 4x. I'm going to try 2 and 2 first. And I know that if I do plus and minus, if I FOIL this out, I'm going to get 4x squared plus 14 minus 2 is plus 12 and minus 7. So that works out. And when I solve these, I will get 1/2, and here I will get -7/2, but it's a width, and I can't have a negative width, so I know it's going to be 1/2. So I know that my width is going to be 1/2 of a foot.